In this video, I'll be teaching you inverse function and the graphs of inverse functions. So first things first, let's start with a normal function. Let's say f of x equals x plus 2. This is a normal function. All it's doing is adding x to 2. All we have to do is understand what an inverse function is first before we can actually find an inverse function. How a function works, is you place a value of x into the function and what you get is an answer. What an inverse function does, it takes this answer and turns it back into the initial value, which was x. Now we learn how to make this inverse function from this normal function. Let's start with this function first. What we have to do first is follow these steps, take notes of these steps as well. This applies to each and every function that exists, this method of finding an inverse function. First, let's write it as a normal equation. We'll change the f of x for a y equals x plus 2. Now what we have to do is, right now y is the subject of the equation. We have to make x the subject of the equation. So in this case it's really easy. We just have to move minus 2 over there. So it will be y minus 2 is equal to x. So x is equal to y minus 2. Now that we've made x the subject, we just have to change x to f inverse of x. The notation for f inverse of x is just an minus 1 above f in the same f of x notation, and we'll change this y to an x. So this is the inverse function. Let's go over the steps again. First, we changed f of x to a y. We made it into a normal equation. Then we made x the subject. Now that x is the subject, we changed x to f inverse of x and changed y to x. This applies to every inverse function that we can make. Let's try this again with a more complex equation. Now let's try something more complex, like let me see. This should do the job. Now let's follow the same steps we did before. First things first, change f of x to a y. Next, we have to make x the subject. So first we'll take y over there. It will be 6 over there. It will be 6y equals 5x plus 7. Then minus 7 will come here. It will be 6y minus 7 equals 5x. Now 5x will come down here. It will get divided. So this will become 6y minus 7 over 5. Now that we've done this, the last step is we have to change x to f inverse of x. F inverse of x. And we have to change y to x. So it will be 6x minus 7 over 5. This is the inverse function. The rule that I told you before, that it changes the answer into x again. Let's test that out. Let's say we put 5 into the normal function. So basically f of 5. This will become 5 into 5. I put 5 in x. F of 5. So it will become 25 plus 7, 32 over 6. 32 over 6, let's just leave it there. Next thing, now that this is the answer, let's put it back in the inverse function. So we should get 5. Technically speaking, we should get 5. Now let's try it. Let's put 32 over 6 the answer. 6 into 32 over 6 minus 7 over 5. This will cancel out. 32 minus 7, 25 over 5, and we get 5, which was the value of x in the first place. This concludes my explanation of inverse functions. Now you should be able to find the inverse of any function really easily. Just follow these steps. The steps, I'll repeat them one last time. Change f of x to y, then make x the subject, then change x to f inverse of x and y to x. Those are the steps. Follow them and you will find the inverse of any function. Now it's time to learn how to make the graph of an inverse function. And in this video I'll show you how to draw the graph of an inverse function and how it relates to the graph of the original function. Let's say this is the y-axis and the x-axis, and first we need an example so that I can show you how it goes. Let's take an example of a really simple equation like f of x equals x plus 2 that we just did recently, and the inverse was f inverse of x equal to x minus 2. Now let's sketch these two graphs. They're really simple graphs. Over here there's 2, over here there's minus 2. One graph would go like this, and the inverse graph is this. So this is f of x, and this is f inverse of x. Now one thing you'll notice is these two graphs are similar. You can they're flipped versions of each other. And where are they flipped about? They're flipped about the line y equals x. Let me draw y is equal to x. They're flipped about y equals x. So if we use this line as a mirror, y is equal to x as a mirror, they're flipped about this line like this, the graph and its inverse. Now let's test this same theory out on another graph. Let's erase this first. Let's say it's now 2x and the inverse would be half x. So let's draw the graph of these functions. 2x would be like this and half x would be like this. So as you can see, again the graph has been reflected off the y is equal to x line. First it was like this, now that it's reflected it's like this. This is as simple as the explanation gets. All you have to do is reflect the graph of the y is equal to x line. Let's try it with a quadratic equation as well. Let's say this is now f of x is equal to x square. Now this will be f inverse of x is equal to under root x plus minus under root x. So the basic graph of the quadratic will go like this. And in order to find the inverse, I'll just have to flip it about y is equal to x again. The red line is y is equal to x. This part will flip over, it will come like this. This part will come over here. And this part will be reflected over here. As you can see, I just reflected it off the y is equal to x line and I found the graph of the inverse function. This is the graph of y is equal to x square, actually f of x. And this is the graph of f inverse of x is equal to plus minus under root x. So this is really easy. All you have to do is flip the graph at the y is equal to x line and you find the graph of the inverse function. That's all there is to the inverse functions chapter. I'll be seeing you in the next video.